Hello students, how are you all? Welcome back to Akshar IT Foundation classes. I am your chemistry faculty S. Mohan. So today, 8th class, right? 8th class we are going to start a new chapter. That's the last and final chapter of this year in this IIT Foundation course, right? And this chapter is the behavior of gases. So name itself it indicates that behavior of gases, how the gases behave under different conditions. That's simple. So if you have it material, open the page number 91. So the synopsis 1, behavior of gases in that gas laws. So before going to that, let first small slight introduction. So gases, behavior of gases. So in that first, let us see the matter. You know what's the matter. Matter means anything which has a mass and occupy the space, right? And matter exists in three states called solids, liquids and gases. And already we discussed the properties of solids, liquids and in the previous classes, right, the volume 1, right? So here students, here main properties, here gases are associated with 4 properties. One is mass, second one is volume, third one is temperature, fourth one is pressure. Okay, so mainly gas associated with the 4 properties. Okay, 4 quantities. One is mass, second one volume, third one temperature and fourth one is pressure. Okay, and basics of all this you know, I think. Mass means what? The quantity of matter is called as a mass. The quantity of matter is called as a mass, and mass is measured in kgs. The SI unit is a kilogram. So here the system of international means what? SI unit is a kilogram, but it's also measured in CGS system. In CGS system it is measured in grams, right? And next here you see, already we discussed in the stoichiometry that the mass of 6.023 into 10 to the power of 23 molecules of a gas is known as gram molar mass. Means what? Any substance, if it consists of 6.023 into 10 to the power of 23, like for example, if you take the hydrogen, okay, 1 gram of hydrogen if you take, that consists of 6.023 into 10 to the power of 23 hydrogen atoms. So that's called what? A gram atomic mass, right? If you take the hydrogen molecule H2, okay, so if any gas it consists of 6.023 into 10 to the power of 23 gas molecules, hydrogen molecules, then its mass is a gram molecular mass, like this. Okay, this already in the last chapter only we discussed, and we have a formula of a number of moles is equal to mass by molecular mass, right? So N is a number of moles here, and small m is the mass of the gas in grams, and capital M is mass in the molar. Okay, so this is about the mass, right? Now then come to the second one is volume. You know that the space occupied by the gas is called as a volume. Yes, the space occupied by the gas. For example, this room is there. Here, what is the volume of the gas in this room is what? We say that the volume of the gas of this room is nothing but a volume of this room, right? So everywhere in this room the gas is there, right? If you take one small room, then what is the volume of the gas inside that room is? You can say the volume of that room. So here gases occupy the space available to it. If you put in a small jar, it will occupy the space of the jar. If you put in a big room, it occupies the big room. Okay, so the volume is nothing but a space occupied by the gas. Generally, volume is expressed in liters. Of course, it's expressed in milliliters also, but liters is general way. Okay, so see now, volume of a gas, okay, is measured with the burette or odometer. That is okay, and the SI unit of this volume is a cubic meter. Okay, and 1 liter is equal to 10 to the power of 3 cubic meter. This you have to remember. So here we have to do some numericals there. In solving the numericals, we require this one. And 1 cubic meter is equal to 1000 liters. Okay, this is also equal to 10 to the power of 6 milliliters, right? Next, this already in the stoichiometry in the last class we discussed that at STP means what? At standard temperature and pressure, 1 mole of any gas occupies 22.4 liters, right? So you see the volume occupied 1 mole of gas under STP conditions occupies 22.4 liters, that is 22,400 ml. And what is the standard temperature? Standard temperature is nothing but 0 degrees Celsius, which is also equal to 273.15 Kelvin. And the standard pressure is what? 1 atmospheric pressure, 1 atm, and under that conditions the gas, 1 mole of gas occupies 22.4 liters, right? So that's about the volume. Next is what? Temperature. You know the temperature, so temperature of the gas is measured in Celsius scale, but it is not SI, it's SI unit. The SI unit of the temperature is what? Kelvin, okay? So here the temperature of gas expressed in the absolute scale, that's called as a Kelvin scale. And here 0 degrees is equal to 273 Kelvin, remember that? Okay, 0 degrees Celsius is equal to, and 0 Kelvin is equal to minus 273 Kelvin. This you have to remember. Okay. So here the absolute 0 is minus 273. See here minus 273. I am not writing 0.15. Round figure I am taking. And the temperature of the gas absolute scale is equal to K is equal to C plus 273. This is a formula. If you are given the Kelvin, if you want to convert the Kelvin in Celsius scale, then C plus 273. Like for example, if I was given now no room temperature, for example, you think now the room temperature is for example 27 degrees, let imagine. So the room temperature is 27 degrees Celsius. If you want to convert into Kelvin, so how can you convert? So Kelvin is equal to C plus 273. So 27 plus 273. So that is equal to 300. So 300 Kelvin. The meaning is what? 27 degrees Celsius is equal to 300 Kelvin. Right? For example, they are given the Kelvin, and they ask you to convert into the Celsius scale. For example, they are given the boiling point of water is 373 Kelvin. Boiling point of water is what? 373 Kelvin. They ask you to convert into the Celsius. So what we can do? To convert the Celsius, then what you have to do? K minus 273 you have to do. Here K is what? 373. So 373 minus 273, that is equal to 100 degrees Celsius. You know that the water boiling point is 100 degrees Celsius. Correct? So this is about the temperature. Okay. Now the last and final one is what? Pressure. Pressure means what? The force per unit area. Pressure is what? Force per unit area. So P is equal to F by A. Pressure is equal to force by area. So the pressure of a gas is defined as a force per unit area. Okay. And the formula is what? P is equal to F by A. So how can you measure the pressure? The pressure can be expressed in different ways. The pressure of a gas expressed with manometer, measured with manometer. And atmospheric pressure is measured with barometer. This already I think you might have learnt in the lower classes. And with the barometer, okay, 1 atmospheric pressure is equal to 76 centimeters or 760 mm of mercury. Okay. And the CGS unit of pressure is, this is very important. CGS unit is dynes per square centimeters, and SI unit is Newton per square meters. Why? So you know that the force is measured in newtons, and area formula is what? Length into breadth. So unit is what? Meter square. So Newton per meter square. Okay, or we can write if m square is taken there, m to the power of minus 2. So like this also we can write. Right. But the SI unit of the pressure is Pascal, student. This is very, very important again. So the SI unit of the pressure is what? Pascal. Generally we express in terms of newtons per meter square. Okay, in terms of dynes per centimeter square, in terms of atmospheric pressure, 1 atmosphere or 76 centimeters and so on. But the SI unit is a Pascal. Very important point. This is Pascal. Okay, and here 1 atmospheric pressure. Okay, 1 atmospheric pressure means the pressure exerted by the atmosphere at sea level is called 1 atmospheric pressure. The 1 atmospheric pressure value in different units or see these are 1 atmospheric pressure is equal to in terms of dynes per cubic square centimeter is this is 1.013 into 10 to the power of 6 dynes, and in terms of SI unit is this one. Okay, in terms of Pascal is this one, in terms of bar is this one, in terms of kilopascal is this one. So these are the different values of 1 atmosphere in different units. Okay, so you have to remember this one. Clear? So that's all about the mass, volume, temperature and pressure. Okay, so these now why the question is that, sir, why we are discussing only mass, volume, pressure and temperature? Because these are the most important okay, physical quantities which affect the gas. Okay, so it affects the gas. So that's what we are taking these four. Okay, now our next topic is gas loss. Gas loss. So gas loss means what? Here the loss which gives the relation of a gas among the pressure, volume, mass and temperature are called a gas loss. Okay, the loss which gives the relation, between the among the pressure, temperature, volume and mass. These loss are called gas loss. Okay, so in the gas loss here in this first synopsis, we are going to discuss mainly about the three important gas laws. One is called Boyle's law, second is called Charles law, and third one is called Avogadro's law. These are the three laws we are going to discuss. The first one is Boyle's law, second one is Charles law, third one is Avogadro's law. And by using these three equations, one equation is also there which is called as the ideal gas equation. Okay, on combining all these three equations, we get one more equation which is called as a ideal gas equation. So till here we are going to discuss in this synopsis. Okay, in the first synopsis today, right? So chalo, first let us see the Boyle's law. Okay, Boyle's law, what it states is, students, very simple law. The pressure or the volume, you can say volume, the volume of given mass of a gas, the volume of a given mass of a gas. In short, V, I'll write the volume. V stands for volume. The volume of a given mass of a gas, means mass is constant. Okay, the volume of a given mass of a gas is inversely proportional to the pressure. Is inversely proportional to the pressure when at a constant temperature. So here temperature and mass, instead of mass we write number of moles, are constant. Okay, so meaning is what? Constant means what? For example, this is a room. In this room I am not changing the temperature. In this room I am not changing the temperature. For example, my AC is running here and here I kept it 24. Okay, so here 24 degrees Celsius I adjusted. So here this room has a temperature of 24 degrees Celsius. So the temperature is constant. Clear? Now here I will take one cylinder. For example, you know the cylinder? Okay, like one will take one cylinder. Okay, this is a cylinder. In this the gas is there. Okay, the cylinder is for example, you think 10 liters cylinder. What is the cylinder volume? 10 liters of a cylinder. Okay, so 10 liters of cylinder. This is 10 liters of cylinder, right? Now, what is the volume of gas? 10 liter, because 10 liters, because the gas occupies the total volume available. So, it's occupying the total volume. Okay. Now, what I do, I'll put one piston here. Piston, you know the piston? Okay, piston. And I apply the force. Means what? I'm applying the pressure. I'm pressing it. Okay. On pressing, what happens? This piston will be coming here. This piston will be coming here. Now, what about the gas? Now, the total gas in this only. Now, the total gas is here. Okay. So, the gas is compressed. So, I am increasing the pressure. So, what happens? Now, the volume is only this much. Okay. So, this is 5 liters. So, meaning is what? As the pressure increases, volume will be decreases. As the pressure increases, volume will be decreases. So, meaning is what? Volume is inversely proportional to the pressure. So, this is called Boyle's law. Okay. So, Boyle's law, what it says here now? At a constant temperature, see, at a constant temperature, the volume of given mass, means what? Mass is also constant, but instead of calling mass, we are telling the number of moles. Okay, is inversely proportional to its pressure. Inversely means reciprocal. Inversely proportional to its pressure. Right? Now, what I do? V is equal to, when I remove this sign, proportionality sign, I think you should know the proportionality sign when I remove, I'll get one constant, that is K. And K into 1 K, so this becomes P. And when I take this P here, so this becomes PV is equal to K. PV, K means what? K is constant. K is what? Constant. The meaning is what? The product, PV, product means what? Multiplication. The product of pressure and volume of a given mass of a gas at constant temperature is constant. Like this also we can see. So now see here, at constant temperature for a given mass of gas, the product of its volume and pressure is constant. The product means what? Multiplication of pressure and volume is constant. That's all. Okay. So in this way, we can write. And you know that mass, okay, what you know the density, you know the density in terms of density, if I would like to define it. Density means what? Mass by volume. Yes, density, mass by volume. So density is directly proportional to the mass. Density is directly proportional to the mass. So in terms of density, for a given mass of a gas at constant temperature, the density of the gas is proportional to the pressure acting on it. Okay, so the density will be directly proportional to the pressure. Means as the pressure increases, the density of the gas also increases. So this Boyle's law we can define in the first way, second way, third way. But mostly used definition is this one, first one. At a constant temperature, the volume of a given mass of a gas is directly proportional to its, inversely proportional to its pressure. Okay. So now see, like this we can write it. Okay. So here the same thing here it is given. See, now see here PV is equal to constant. For example, I have, so this one you can see here. Here, for example, initial volume. First is 10 liters, I said no. Initial volume is P1 and initial pressure was P1. Initial pressure was P1. Now, second time I applied the pressure, so I changed it the pressure from P1 to P2. Then what happens? Volume is reduced, so volume is also changed to P1 to V2. Now what we have? P1 V1 is equal to PV is equal to constant. So I apply to this one. Then it becomes what? P1 V1 is equal to constant. Okay. Now the same formula I will apply this one here. Okay. So PV is equal to constant. P here P2, V here V2. So this becomes P2 V2 is equal to constant. Okay. So P1 V1 is equal to K. P2 V2 is equal to K. Both are K. So what can I write now? P1 V1 is equal to P2 V2. Like this we can write, right? So P1 V1 is equal to P2 V2. Like this also we can write. Clear? And next one is what? Density is directly proportional to the pressure. So see here now, density is directly proportional to pressure. So what we can write now? D1 is directly proportional to P1. D2 is directly proportional to P2. So this we can write proportionality sign if we get D1 is equal to K into P1. This we write D2 is equal to K into P2. Now divide this both, K get cancelled. D1 by D2 is equal to P1 by P2. Correct? So see here now, like this. Correct? Otherwise you can write this D1 bring here, this okay P2 bring here. That becomes what? See here. This D1 I am taking this right. So this becomes what? Here. Okay. P1 by D1 it becomes. So yes. So P1 by D1 is equal to this P2 I am bringing here. So P2 by D2. P1 by D1 is equal to P2 by D2. That's all. So that is called as Boyle's law. Is this clear? So Boyle's law states what? At a constant temperature, the volume of a given mass of a gas is directly proportional to, inversely proportional to pressure. Okay. So that's about the Boyle's law. Clear? Now, here you see, this is very important. So this Boyle's law, PV is equal to constant. So we have how many equations here? First one, P is equal to K by V or PV is equal to K. Okay. Two equations we had here in the previous slide, right? So here. So where is the C here? V is equal to K by P or PV is equal to constant, right? So if we plot this values on the graph, okay, so what you'll get? So the shape of the graph, these are the graph students here. One more important point is that here the graphs plotted, okay, between the pressure and volume are called isotherms. What they are called? Isotherms. Why? Because Boyle's law at constant temperature. Iso means what? The same. Therm means what? Temperature. So here at the graphs plotted between pressure and volume of a given mass of a gas at constant temperature are called isotherms. This you have to remember. Now see the graphs you see here. Here I'll explain you. So here what I said, the volume of a given mass of a gas is inversely proportional to pressure. Means what is the volume increases, pressure decreases, volume increases, pressure decreases, right? So for example, you see now, for example, V, here I will take, P I will take. So first, P volume 100 liters you think, and pressure is some 10 Pascal, okay. Now we are increasing the pressure, for example, this is not exact values, example, okay. Here then if I am taking the 20, maybe it comes to some 80 or something, right? Okay, and if I will take the some, not 20, here I will take, okay, 20, and if I take 30, for example, the pressure, see, pressure is increasing, so volume decreases, okay, 30, and if I am taking 40, here I am getting 80, sorry, 100, 80, 60, 40, okay. So like this we are getting, are you following what I am telling? Okay, so as the pressure increases, volume decreases, correct? Now if you plot the value, you know the graph, how to draw the graph? So this is x-axis, this is y-axis, on the x-axis we are putting x-axis we are putting the volume, and y-axis we are putting the P. So see here, P is the pressure. Pressure is 10, 20, 30, 40, okay? So here 10, 20, 30, 40, okay? And volume is like 60, 80, 100, something like this, okay. So now volume is 100, so this is volume is 100, here volume is 100, the pressure is what? Pressure is 10, so pressure is 10, so the point comes here. You know how to draw the graph. Now the pressure is 20, okay, are you following? So if the pressure is 20, this is 20, and volume is 80, so pressure is 20 and volume is 80, okay. I'll draw very clearly in another slide so that you can understand. Here the slides are, there's no space for the slide. Also students, now see here, Boyle's law, what it says is V is inversely proportional to pressure. So V is inversely proportional to pressure means what? If the volume increases, pressure will be decreases. Is this clear? Okay. If one quantity increases, other quantity will be decreases. For example, you take some V values and P values. Okay. So here what we do, for example, you see volume is some 100 liters. Okay. Then we take 50 liters. Okay. Then we take 75 liters. Then 50 liters and 25 liters like this. So volume is decreasing, okay. And here, for example, you think the pressure is 1 atmospheric pressure. I am increasing the pressure 2 atmospheres. The pressure is increased 3 atmospheres, and pressure is increased 4 atmospheres. So 100 liters, 75 liters, 50 liters, and 25 liters. When the pressure is less, the volume is more. When the pressure I am increasing the pressure, so volume is decreasing. Is this clear to you? Now if you want to plot the graph for this one, okay, how can you plot the graph here? So see now. So here what I am doing here, I am taking, okay, I am taking here V, okay, V along the x-axis and P along the y-axis, right? So here this is the x-axis, volume I am taking here, and the pressure I am taking here, okay. So volume, so I am taking this is 0, right, 0, and this is 25, this is 50, this is 75, this is 100, okay. These are the volumes. Now pressure, what I am taking, pressure here 1, here 2, here 3, here 4, okay. So now see here, when the volume is 100, the pressure is 1. Volume is 100, so I'll take some other color here, yellow color I'll take. So volume is 100, the pressure is 1. So 100 and 1, where they are meeting at this point. This is a point. Now when it is 75, pressure is 2. So volume is 75, pressure is 2. Okay, 75, pressure is 2. So here it is, right? Now here 50 and 3. So 50, some 3 here. Okay. So the meaning is what here? So now what's happening? The volume like okay. So here the volume actually what's happening is as the pressure increases, volume will be decreases. As the pressure increases, volume will be decreases. So you'll get this type of a graph. So the same type of graph is shown here. Can you see here? Okay, so this is a graph. So in this graph, the shape of P versus V. P means what? Pressure, and V is called the volume. So the shape of the P versus V graph is a hyperbola, and this is called a hyperbola. Clear? Similarly, here you can see in the previous slide. So V is inversely proportional to P I written. Yes or no? So see or no? V is inversely proportional to P. V is inversely proportional to P. I can write like this also. P, if I bring here, V comes here. Okay. So P is coming here, V is coming here. So P is inversely proportional to 1 V. So P and here, so P is equal to, so if you remove this one constant, into 1 by V. So if I plot the graph between P and 1 by V, okay, if I plot the graph between pressure and 1 by V, then we'll get the straight lines. We'll get the straight lines. And based on this also we'll get the questions. So here if you see these three, here this is one line, this is second line, this is three lines. So at different temperatures. Okay. So here where the temperature is more means what? This is the temperature is more than this one, This is the least temperature. Okay. So this is. And pressure versus PV. Pressure versus PV means what? Here, see here. Here you can see here. P is proportional to 1 by V. So I am removing this one. We get one constant, I said. Constant divided by V. Now V I am bringing here. So this becomes what? PV. PV is equal to K. If I plot the value between this PV and V, PV and P, then I'll get the straight line like this. So these are the different types of graphs we can get if we plot the values of pressure, volume, pressure and 1 by V, reciprocal of volume, and the product of PV and pressure, and V and 1 by P. So these only V and P, but we are changing. Okay. So on taking the different quantities, so you will be getting the different types of graphs. So this here you have to remember what type of graph getting when you are plotting. So when P and V, hyperbola. When P versus 1 by V, here PV, here 1 by V. So then we are getting the straight lines, and here PV, this is like slopes, and pressure and PV, you will be getting the horizontal line. Okay, and V and P, we are getting this line. So this type of lines we can get, and these graphs are called isotherms. All these graphs are called isotherms. Remember that. Next, here very important point here. The gas laws obey the boils at a low pressure and a high temperature. This is very important. So whether the gases obey this Boyle's law under all conditions? No. Okay. So here they do not obey the Boyle's law. Not only Boyle's law, we are going to discuss about the Charleston and Avogadro's law. This all the gas laws cannot be obeyed by all the gases under all the conditions. Okay. So under which conditions they obey the Ohm's law? Obey the Boyle's law. So they obey the Boyle's law when the temperature is high and pressure is low. This is a condition you have to remember, very important. Okay. So that's about the Boyle's law. Clear? Now then come to the Charles law. Here you see in the last one, Boyle's law, we kept the temperature constant. Volume of given mass of a gas is inversely proportional to the pressure when the temperature is kept constant. Correct? Here what we do, pressure we kept constant and T we bring here. Okay. Then what happens? Definition see now. The volume of given mass of a gas, okay, is directly proportional to temperature over here. Directly proportional to temperature at constant pressure. So in the first Boyle's law, we are keeping the temperature constant. But here we put the pressure constant. Okay. So that's the change. Okay. So here what it says, so the volume of given mass of a gas is directly proportional to the temperature. The meaning is what? If the temperature is more, if you increase the temperature, the volume of the gas will be increases. Yes, you know, I think this in the lower classes you have done some experiments. For example, if you take one okay, one empty bottle. Okay, you can take just one empty bottle. This is empty bottle. Okay, this is empty bottle. And in this empty bottle, okay, now what you do, you take one balloon, and just to put the mouth of the balloon, fix the mouth of the balloon to this one. Okay, to this bottle. Now, you are not blowing air anything. Okay, just you put the balloon like this. Now what you do, you heat this bottle. On heating bottle, what happens? This balloon, okay, it is a balloon, now it will be bulge just like this. Okay, this bulge just like this. Yes or no? Why? Because on heating, the gas is expanding. The volume of the gas is expanding. So, this is going away from the bottle. But the bottle mouth is fixed to the balloon. So, the excess of air is going into the balloon. So, the balloon becomes big. Yes or no? So, here the on heating means on increasing the temperature, the volume of the gas will be increases. That's all. This is called as a Charles law. And Charles law, see here, Charles law, at a constant pressure. So, pressure should be kept constant. The volume of a given mass of a gas is directly proportional to its absolute temperature. Directly proportional to. So, meaning is what? V is directly proportional to T at when the pressure is constant. When the pressure is what? Constant. That's all. So, we can write V is equal to some K into T. Okay. So, if you bring T here, V by T is equal to K. If you put the conditions, V1 by T1 is equal to V2 by T2. This is formula we get. Okay. So, this is about the Charles law. Okay. So, here as the temperature increases, volume increases. Okay. But how much volume increases? To say that, here one more in detail it is given. To every 1 degree rise of temperature, for every 1 degree rise of temperature, the volume of gas increases by 1 by 217th part of its original volume. So, see here, at constant pressure, the volume of a given mass of gas increases or decreases by 1 by 273 times of volume at 0 degrees for every 1 degree rise or fall of temperature. Means what? If 1 degree temperature is raised, then what was its actual volume at 0 degrees? For that volume, 1.1 by 273 part of that will be increases. Okay. So, this is in detail. Okay. So, that's called as a Charles law. Okay. Then last and final one, here Charles law, students, here Charles law, if you plot the graphs here between the Charles law, here they are called isobars. Why isobars? Because what is constant in the Charles law? The Charles law, the constant pressure. Pressure is measured in bar. Pressure is measured in what? Bar. Bar is also one of the unit of the pressure. So, isobar. Iso means what? The same. Bar means what? Pressure. So, constant pressure means what? The same pressure. When you maintain the same pressure, and if you plot the graph between the volume and the temperature, log value and log temperature, then we'll be getting the this type of graphs, and these graphs are called isobars. So, you know that whenever it is directly proportional to, then we'll get one straight line. Okay, slope will be straight. Okay, so that is about the Charles law. Okay, now last and final law, Avogadro's law. Avogadro's law, what it states is, under same conditions of temperature and pressure. Otherwise, we take at STP. Okay, at STP, 1 mole of any gas occupies 22.4 liters. Already we discussed this in the stoichiometry in the previous chapter, right? So, here slightly what we say is, under same conditions of temperature and pressure, the volume of given mass of a gas is directly proportional to number of moles. Means as the number of moles increases, volume also increases. Yes or no? For example, taking 1 mole of gas, at STP it occupies 22.4 liters. Okay, if you take 2 moles of gas, it occupies double. 22.4 means what? 44.8 liters. Yes or no? So, as the number of moles are increasing, the volume is increasing. So, V is directly proportional to N. That's all. So, here, equal volumes of all gases within the same conditions of temperature and pressure, it is equal number of molecules. Like this also you can say, like this you say, at a constant temperature and pressure, the volume of a gas is proportional to the number of moles. So V is directly proportional to N. V is directly proportional to N. When you remove proportionality sign, V is equal to K into N. If you bring N here, V by N is equal to constant. If we put two conditions, V1 by N1 is equal to V2 by N2. Over, that's all. Okay, V1 by N1 is equal to V2 by N2. So, that's all about the gas law, students. Other laws are there. Dalton's law, partial pressure, and Graham's law of diffusion. Other gas are there that we discussed in the second synopsis. But now, as of now, so here the gas laws are finished. So, these are the main three important gas laws. One is called Boyle's law, second is called Charles law, and third is called Avogadro's law. And in simple way, if I would like to say how we can write the Boyle's law. So, Boyle's law is inversely proportional to pressure when the temperature and N is a constant. And Charles law, V is directly proportional to T when pressure and N is a constant. And third one, Avogadro's law, V is directly proportional to N when temperature and pressure is constant. That's all. These three are the Boyle's law, Charles law, and Avogadro's law. Did you understand? Any doubt? So that is about this one. Okay. Now here, students, gases are two types of there. Gases are how many types? Two types of gas are there. What are they? Ideal gas and real gas. Ideal gas and real gas. What are ideal gas? The gases which obeys all the gas laws under all conditions are called ideal gas. Okay, the gases which obey all the gas laws means what? Boyle's law, Charles law, Avogadro's law. All the laws they obey under all the conditions. Whatever the conditions, if you obey, they are called ideal gases. Okay. Real gases means what? The gases which do not obey these gas laws under all conditions. They obey, but not under all conditions, under particular conditions. So the gases which obeys the gas laws like Boyle's law, Charles law, Avogadro's law, under particular conditions, they are called as real gases. So meaning is what? To be frank, so there are no ideal gases. Okay, only we have the real gases because all the gases do not obey all the gas laws under all the conditions. Okay, so that is very important. So ideal gas here, the gases obey ideal gas equation under all any conditions, and real gas are what? Which do not obey all the gas laws under all the conditions are called real gas. Okay, now here it comes to ideal gas equation. So students, ideal gas equation is nothing but a PV is equal to nRT. What is the ideal gas equation? PV is equal to nRT. Okay, this is ideal gas equation. Sir, how can we get this equation is what here I said. Okay, so see here, V is directly proportional to 1 by P, V is directly proportional to T, V is directly proportional to N. If all I combine, see V is there, right? In all the three cases, V is there, so I am writing V. And all the cases proportionality is there, so proportionality. Here 1 by P, so I'll write 1 by P. Here T into T, here N into N. Now this P I am bringing this side, so this become PV is directly proportional to T into N, Tn. If I remove this one, we get one constant, so I can write PV is equal to in the place of this, so I am taking one constant, that is R I am taking, R, T, N. So in alphabetical order of what if I write PV is equal to nRT. What I'll get? PV is equal to nRT. So this is that. Okay, PV is equal to nRT. I went. So here PV is equal to nRT. Already written. Did you understand? So the PV is equal to nRT. This equation is derived from the gas laws, from the three gas laws. What are this? Boyle's law, Charles law, Avogadro's law. From these three laws, okay, one equation is derived. That equation is called ideal gas equation. If any gas is obeying this ideal gas equation under all conditions, then that is called, they are called ideal gases. Or the gases which do not obey, okay, this equation P is equal to nRT under all conditions, which are called real gases. Clear? So shall once go through this one. So finished, students. So that's about the ideal gas equation. Okay. Now let's go to the next topic. application of equation of state. So see students here, application is nothing but a uses. What the use of this ideal gas equation? See students here, if we know any two quantities, PV is equal to nRT, total 5 are there, and of course in that R is a constant. The R is called universal gas constant, and PV is equal to nRT, total 5 are there. R is constant, remaining 4. In this 4, if we know any 2, the remaining 2 we can find by using this equation. Okay, if one gas is given, okay, for example, I said no, now my room temperature is 24 degrees Celsius. At this I am taking one gas in one cylinder, okay, and what I am doing, I am increasing the temperature, okay. So now increase the temperature or decrease the temperature. Is it change the volume? Yes, I can find what is the change in the volume. Okay, so like this, I can change, means I can find the relation among this one. So there are the applications. So here you see, here that equation can be written different ways. Just now I told you how to write. So here I give what? PV is equal to nRT, correct? So this n number of moles constant, R is constant. For example, I am maintaining the temperature, otherwise T bring this side. So this becomes PV by T is equal to nR. nR both are constant. Constant means what? Always same. Now this I will put the conditions. P1 V1 by T1 is equal to nR. So another, say in the similar way, I let P2 V2 by T2 is also equal to nR because this is constant. Now this is equal to this one, but this is equal to this one means what? This is equal to this one. A is equal to B, B is equal to C. The meaning is what? A is equal to C. So P1 V1 by T1 is equal to P2 V2 by T2. So like this we can write the equations. Okay, and so this is about the ideal gas law, and this is called general gas equation. So this is very important. This equation is highly useful to calculate the volume change in the gas when both the temperature and pressures are changed simultaneously. So when there is a change in the temperature and pressure, if you want to find the volume, okay, of any gas, so we can find by using this equations. Clear to you? So that is about this one. So similarly, we can write in different forms also. So here it is P is equal to nRT. So here in the first slide I told you that the pressure PV can be expressed in terms of density. See here, it is density in terms of density. So here also we can PV is equal to nRT, the same equation. Wind can be same equation. We can be expressed in different forms. Okay, you know that density is equal to mass by volume, right? So like this, by using this mass, we have the mass and volume, number of moles, all these things are there. So by using this, we can write the PV is equal to nRT. nRT, so here PV is equal to nRT. But PV is equal to N means what? Number of moles, weight by molecular weight. So weight by molecular weight, N is equal to weight by molecular weight. So I am putting in the place of N weight by molecular weight RT. So now this becomes this one. Clear? Okay. Now you see this V if I bring here. Okay, if I bring here, so mass by volume becomes density. Mass by volume becomes what? Density. So here now this equation I can write like this: P is equal to W is a W. This V I am bringing here V into 1 by M. Okay, RT. Correct? So P is equal to weight by volume is nothing but a density. Weight by volume is what? Density. So density into RT by M. Okay, P is equal to dRT by M. See here, P is equal to dRT by M. Alright, so like this, we can write the equations whatever the manner we required. In that way, we can write it. Okay, students, so I can write like this. If I put the conditions here, the same thing, I put just one. So P1 is equal to dr d1 r1 t1 by m1. Then if I change something here, pressure or something, so this also will be changes. So P2 is equal to D2 R2 T2 by M2. Correct? So now in this one, we can also write in this one also see here, P1 is equal to D1 RT1 by M, dP2 is equal to, in this also we can write. So whatever the equations we want, okay, in which form we want, we can convert these equations. Okay? So that is about the other forms of equation. Now, this is also very important, numerical values of R. So here I give that PV is equal to nRT. This is the ideal gas equation. P means pressure, V means volume, R is, N is number of moles, T is the temperature, but R is constant. Constant means what? Which has a particular value, and this value will not be changed anywhere, okay, any time. So this value is always remains the same. That's what it is called. R is called universal gas constant. What it is called? Universal gas constant. R is called universal gas constant. Universal means what? Anywhere, anytime. So the value remains the same. Okay, how can we take this value? Okay, so very simple. So see here now, PV is equal to nRT. This is our formula. I written here. Okay, so see. Okay, so here you see PV is equal to nRT. I want only R. So what I do, this N and T, I'll bring this side. So then equation becomes R is equal to PV by NT, correct? PV by NT, right? So here now R is equal to, put its values. R is equal to P. Pressure is expressed in terms of atmospheric pressure. Okay, so we can take P is equal to 1 atm. Means what? 1 atmospheric pressure. 1 atm. 1 atmospheric pressure. Volume. 1 mole of any gas occupies 22.4 liters at STP. Already I said you that. So that is, we write 22.4 liters. Okay. Divided by N. N is number of moles. I am taking 1 mole. And the temperature. Temperature is measured in Kelvin. The SI unit of the temperature is Kelvin. So write 273. Clear? Kelvin. Now see here. 1 into 22.4 is equal to 22.4. Atmospheric pressure atm liters divided by 1 into 273, here 1 mole, so mole into Kelvin, right? If you divide 22.4 by 273, you will get 0.082. How much you will get? 0.082. So see a liter, L, atm. Here divided by mole is there. So I am taking this mole up, and here also this Kelvin is also I am taking up. So to the Kelvin to the power of minus 1, mole to the power of minus 1. So in this way, so see here, 0.082 liters, see L means what? Liters, atm means what? Atmosphere, per Kelvin, K to the power of minus 1, and per mole, okay, M to the mole to the power of minus 1. So like this, we can calculate the R value, that is universal gas constant value. Okay, so this value is also very, very important in solving the numericals. Okay, students. Chalo. So with this, we completed this chapter. This synopsis 1. Okay. Now let us solve the questions. Gas laws gives the relation between different of gases concentrations. No. Volumes of gases. No. Measurable properties, yes. So gas laws gives the relation between pressure, volume, number of moles and temperature. So these all are measurable quantities. So the answer is 3, correct? So open the page number in material if you have a page number 99. Okay. So open the page number 99. Right. So gas laws, the relation between, right. Now next questions here. Now the graphs drawn at a constant temperature. Already I said constant is called iso. Temperature means what? Therm. So the answer is isotherm. Isotherm is the right answer. So this is the second one. And where this isotherms graphs we draw at constant temperature, where the in which law the temperature is constant? Boyle's law. So this is also very important. Remember that. Next, the lowest possible temperature for liquefying gas is called absolute zero. What it is? Absolute zero. Okay. And the SI unit of the pressure, Pascal. The SI unit of pressure is what? Pascal. Direct questions. Now, if a given mass of a gas is allowed to expand from the volume of 250 to 500 ml, then the pressure of the gas after expansion was found to be 4 atmospheres. What was the pressure of the gas before expansion? So see students, here 2 conditions here given. volume increased from 250 ml to 500 ml. So see now, here I am taking volume is increased to 250 ml to 500 ml is given in the problem. Okay. At the same time, what is given? Then the pressure of the gas after expansion was found to be 4 atmospheres after expansion. So after expansion means what? The pressure here after expansion, the pressure is given as 4 atmospheres. Then they are asking what is the pressure here, right? So then what we do? You take V1, this is V2, this is P1, this is P2. Now from the Ohm's law, from Boyle's law, we have that term P1 V1 is equal to P2 V2. Yes or no? So apply the formula. P1 V1 is equal to P2 V2. What we need to find? P1 we need to find. This we need to find, right? So what we write now? P1 is equal to P2 V2 by this V1 is coming here V1. Correct? Now see what happens now. P1 is equal to P2. P2 is what? P2 is what? 4. P2 is 4. So 4 atmospheres into V2. V2 is what? 500 ml. 500 divided by V1. V1 is what? 250 ml. So 250. Okay. 0, 0 cancel. 25 ones are 25 twos are 2 fours are 8. So P1 8 is equal to 8 atmospheres. So our answer is 8 atmosphere. Whether the answer is there or not, let's check. Yes. 8 atmospheres. See here, the answer is there, right? So the answer is here 8 atmospheres. Clear? So the option is the third option. Option is what? Third option. Clear? Fifth one. Now sixth one you see here, 20 ml of hydrogen gas measured at 15 degrees Celsius or heated to 35 degrees Celsius. What is the new volume of the at the same pressure? So same students here also, but here you see volume expanded to 500. Here, okay, here 20 ml is given, but here atmospheres, here temperature. That's the difference. 20 ml of hydrogen gas, 15 to 35. Still, see now. Okay, so see the next one. What the sum is given? There is one 15. How much? 20. Sorry. Okay, so there is a 20 ml of hydrogen gas is there. What is there? 20 ml of hydrogen gas is there. For example, this is some cylinder something. Here 20 ml of gas is there. Okay. And when the temperature is 15 degrees Celsius. When the temperature is how much? 15 degrees Celsius. Correct? Yeah, 15 degrees Celsius. And are heated to 35 degrees Celsius. And are heated to, now this is heated to 35 degrees Celsius. Now when it is heated to 35 degrees, what is its volume they are asking? Correct? So now what you need to do? So write volume temperature. So first V1 is 20 ml. Okay. And T1 is equal to 15 degrees Celsius. And V2, we don't know, we need to find the V2. The temperature T2 is given 35 degrees Celsius. Correct? Now, very important point I am going to explain you see. Now, from the Charles law, the pressure is kept constant, the volume of a given mass of a gas is directly proportional to temperature. So, V1 by T1 is equal to V2 by T2. This is a formula for the Charles law. Now, what we want here? V2 we want. So, for that, what we do? V2 we want. So, we can write formula V2 is equal to V1 into T2 by T1. This is a formula. Correct? Now, V2 is equal to V1. So, V1 how much is given here? 20 ml. So, write here 20 ml. Okay, into. Now, see here T2. T2 how much it is given here? 35. But if you write that 35 there, this is wrong. Your problem becomes wrong. Your temperature is given 35 degrees only. But if you write 35, your answer becomes wrong. Why? Because your degree Celsius is not our SI unit. Is it SI unit of temperature? No. SI unit of temperature is Kelvin. So you need to convert this Celsius into Kelvin. So then what happens? To convert the Celsius into Kelvin, you have to add 273. So 15 plus 273 is 288. and 35 plus 273 is equal to 35. So I think 308. Okay, 308. So Kelvin. Now in the place of T2 you write 308. What you write here? 308 divided by T1. T1 is equal to 288. Okay, 288. Oh, this is a very big calculation. Now you need to do it. Okay, so this you need to do it 20 into 308 by 288. 20 into 308 by 288. See students, here I am using the calculator, but you don't use a calculator. Okay, so is what 20 into 308 by 288. 20 into 308 by 228. So 20 into 308 divided by 288. 21.38. Whether it is there in our answer, once you check. Yes, 21.38 ml here it is there, students. So our answer is, this is the right answer. Okay, so that's the right answer. Clear? 21.38 is the right answer. How to solve? You know. Okay, here this is a problem. You need to solve. Some little calculation is required. Right? Chalo. Now let's go to the next one. So here it all 6 are done. So here it is 8, here it is 21.8, here it is a Pascal, it is absolute 0, here it is isotherm, and here it is measurable properties. Right. Chalo, here V versus T curve set constant at P1 and P2. Then ideal gas shows, what it shows? P versus T curves at the constant pressure P1 and P2 are shown in the figure. Your figure is not given, students, here. Your figure is not given. For this question, the figure is not there. So we can't answer it because the figure is not given. Correct? So leave it now. Now, which curve does not represent Boyle's law? PV, correct. And log P, log V, this also correct. PV, this is wrong. See, PV, this is correct. PV, PV, how can the same physical quantities, the graphs are different? This is correct, this is wrong. So which is not correct means what option is the third option. Option is what? Third option, students. So this is the answer for this one. Clear? Now, next one. If the temperature of a gas is doubled from 10 degrees to 20 degrees, then the volume also doubled? No, it will not be doubled. Okay. When it will doubled, for example, if the Kelvin scale is given, 273 Kelvin is given, and if the temperature is doubled to 273 into 2, how much will get? 546. If we bring 546 Kelvin, that will be increases. But in the Celsius scale, if you double it, it will not increase. So the answer is false. Now here, last and final one. There is a gas in a special sphere of radius 2r at a pressure P. It is connected to another sphere R by means of tube whose volume is negligible. Find the final pressure exerted by the gas after connection. So see students, here there is one sphere. Try to understand the question. Here one sphere. This sphere radius is 2r. Sorry, radius is 2r. Okay. So radius means what? Only half, right? So radius is 2r. Now at the pressure P, here the pressure is P is given. Now it is connected to another sphere of radius r only. So here one small sphere is there. It is of radius only r. Okay. Now these are connected by tube. So these both are connected by tube. Now find the final pressure exerted by the gas after connection. After connecting these both the pipes, so what happens? The gas will move here and there. Yes or no? Then what will be the final pressure? So here we need to solve the problem here. So what we do? Okay. here we have a formula from which Boyle's law. So in the Boyle's law we have that P1 V1 is equal to P2 V2, correct? So we have the two spheres, the first sphere, second sphere. Here the pressure is given P, okay, and the pressure we don't know, okay. So what we do for P1 means here the P1 is equal to P you take. The pressure we don't know, so P2 is equal to we don't know, leave it. Now the volume V1 we want, but here the radius is 2r. Do you know what is the formula of the sphere, volume of the sphere? Yes, so volume of the sphere is equal to 4 by 3 pi r cube, correct? So 4 by 3 pi r cube. So V1 is equal to 4 by 3 pi r, but in the place of r what we have to write? Radius is 2r here, so 2r whole cube, right? And here V2 is equal to what? Just this is r only, so 4 by 3 pi r cube over, right? Now we have a formula. We have a formula that P1 V1 is equal to P2 V2. So see now, P, what we want now, pressure P2. So P2 is equal to P1 V1 by V2, correct? So P2 is equal to P1. P1 is what? P. We have taken the P, okay, into V1. See here, V1 see students here, 4 by 3 pi into 2r whole cube. 2r whole cube becomes 2r into 2r into 2r. 2 2s are 4 2s are 8. So this becomes 8r cube. So now I can write this 4 by 3 pi into 8r cube. 8r cube can I write like r cube into 8. I write like this, no problem. Now what I have? V2. V2 volume is what? 4 by 3 pi r cube. So 4 by 3 pi r cube, right? So see here 4 by 3 pi r cube, 4 by 3 pi r cube is cancelled. So P2 is equal to P plus P into 8. So that is 8P. Clear? See, little mathematical knowledge is also required here to solve this problem. See here two spheres are there. One sphere radius is 2r, other sphere radius is only r. And here the pressure of the gas is P. Here the pressure of the gas we don't know. Okay. Now if we are both are connecting with a tube, when I connect the tube, then what happens? The gas will move here and there. So now the pressure will be changes. Now they are asking what is the pressure. So we have the formula that P1 V1 is equal to P2 V2 according to Boyle's law, right? So P1 means what? Pressure P. V1 is equal to volume of the sphere, of this sphere. So here radius is what? 2r. Volume of the sphere formula is what? 4 by 3 pi r cube. Okay. So 4 by 3 pi r cube. But r is what? 2r, you have to take 2r cube. Okay. And P2 we don't know. So write P. V2 volume of this one. So here radius is r. So this becomes 4 by 3 pi r cube. Now on substituting this one, P2 is equal to P1 V1 by V2. P1 is what? P. V1 4 by 3 pi 2r whole cube. This becomes 8r cube. So 4 by 3 pi r cube into 8 I am writing. And by V2 is equal to 4 by 3 pi r cube. 4 by 3 pi r cube, 4 by 3 pi r cube left, cancel. P into 8 is 8P. Whether 8P is there in our answer or not, let's check. Yes, it is there, 8P. The answer is here, right? So the answer is here, 8P, correct? So that's all students for today. So we have completed the practice sheet 1, and next let's try your exercise. You try. If you have any doubt after completion of this, we are going to conduct some classes, right? So in these classes we discuss. Once again, if you have any doubt, okay, doubt clearance sections will be conducted for you. Okay, so with this we stop. The synopsis 1 of the behavior of gases is completed, and it's a very important chapter. Read, learn the formulas and practice.